Good evening, everyone. I'm Dong Yuexi, and my group members are Shizhan, Zhang Ninghao, Wang Ziquan, Li Weikang, and Sun Fan. We're going to present our project focusing on ESG data analysis. This is the outline for our presentation. First of all, what is ESG all about? Actually, ESG is a set of standards regulate a company's behavior in terms of environmental, social, and governance criteria. ESG helps stakeholders to understand how the company is managing risks and opportunity in those three aspects so that they could make sustainability-focused strategic investment. And our project is to build a model to analyze companies' annual public reports and to predict the ESG rating, which is a quantitative assessment of companies' ESG performance of a well-known rating agency called WIN.
Okay, now I'm going to introduce the second part, data collection and data processing. The key data of this project is the company's ESG annual reports, which can be obtained from the official websites of various companies. When calculating a company's ESG scores and ratings, news about the company should also be taken into account as an auxiliary reference. We get our information mainly from a few major news websites. And then we need to get the ESG scores and rankings from the WIN website via company ticker codes as the training labels. These two pictures show part of the data we obtain. The PDF version of each company's ESG report and the 4 years ESG scores and rankings for each company. We can see that the file name structure of the files is confusing. Some even do not have the year of the ESG report, but only the year the report was published. So firstly, we have to use regular expressions to unify the file name structure. And secondly, we need to extract text from these PDF files. And then we can complete missing ESG report years with the year in the PDF text. After this, we need to extract company ESG ratings and scores from the XLSX file. And finally, all data we need should be saved into JSON files for the convenience of future use. This page shows the processed data. For example, CIMC's 2019 ESG report and ESG scores are integrated into the structure on the right. And that's all for part 2.
I'm Zhang Ninghao, and I will give some introduction about the traditional statistic method we used here. As we showed before, our data have a total of 4 scores, ESG scores, and scores for 3 sub-items: environment, management, and social responsibility. I use some traditional statistic method to build some regression models for each of these 4 tasks. In this project, I established 5 methods: boosting tree, MLP, SVM, LAR, and Gaussian process regression. This method have a very good performance in various tasks. Boosting tree combines many weak learning models into strong models. MLP can process a lot of data with complex structure, and the use of the kernel trick in SVM makes its performance for linear problems greatly enhanced. LAR is a very important method to build regression by selecting variables. Gaussian process regression uses Gaussian process as a prior distribution of the data, and this method have a very strong ability of generalization. All of these methods are very good statistical methods to build the model, and it is very difficult to judge which one we used in this project. So I used all 5 methods here to build the model for each 4 tasks. And this is the evaluation result of the model, and we use MSE to evaluate the performance of the model. It can be seen that boosting tree is the model which works the best, so I choose the boosting tree as the method here to build the model. And I choose some hyperparameter here for boosting tree, and the maximum depth of the tree is 1. If this item gets too large, like 2 or 3, we'll get an overfitted model, and the number of estimator is 150 here. And the result of the prediction will be showed later in this presentation.
Part we concentrate on our ESG BERT model. Given that ESG is short on the subjective analysis text, directly applying the sentiment analysis proves inadequate for evaluating a company's actions. For this task, our main approach involves using the company published ESG reports and WINS ESG scores to fine-tune the pre-trained BERT model. Pre-training refers to the processing of using data from various domains or datasets to train a backbone network in advance. Subsequently, we perform the fine-tuning with the collected data, which significantly reduces the conversion speed and that does not require a vast amount of data. The pre-trained language models can learn general language representations from massive corpora and subsequently improve the downstream tasks. In the tasks, we use two baselines, applying different fine-tuning strategies and comparing their performance. They're BERT training and FinBERT. Both of them have extensive pre-training datasets. And ultimately, we comparing their results. We selected the transfer with an adapter as the ESG BERT finally. This model can generate individual ESG scores and total scores for ESG. Simultaneously, the pre-trained transfer can also generate report summaries. The detailed results and chatbot performance will be showcased later. For the chatbot Q&A session, we employ the GPT model. GPT and BERT represents two fundamental paradigms based on the partial parameters of the transformer structure. GPT is more suitable for text generation tasks, while BERT excels in text understanding tasks. We improved the prediction results along with the ESG summaries into the GPT model, which generates corresponding evaluations and suggestions.
But we will mainly conduct a chatbot illustration of our model output. And our chatbot illustration pipeline is shown as follows. First, we save our model output of the ESG prediction. Then, given a question, we first extract company name and the specific year from it. And next, we load model outputs according to the company name. Right after that, we format a complete sentence based on ESG scores via ChatGPT API. And finally, maybe we can give some suggestions based on our ESG predictions. Then we will play a little demo for a reference. Let's say we are interested in the ESG performance of Guizhou Maotai. We simply type in, I would like to know the ESG performance of Guizhou Maotai. Then we wait for a few seconds. Yeah, as you can see, our model chatbot outputs the ESG predictions of our model and as well as some potential suggestions of it. That's pretty much of our whole ESG model and chatbot part. Finally, we will move on to the overall analysis of model performance and conclusion.
Next, I will analyze the results of the model and make a conclusion. Among the 5 traditional models, the ESG model has the best effect. It has the lowest losses in environmental, social, and governance aspects. ESG score loss is only 0.3748, much smaller than the other 4 models. This may be due to the low complexity of the other 4 models, while the ESG model can greatly improve the accuracy and robustness of the model by boosting learning process. In this section, we just simply compare the performance of different types of models on ESG scores. In order to further improve the performance of the models, we can adjust the parameters of the models to achieve higher accuracy. For example, we can increase the number and the depth of basic models, adjust the learning rate, and try different loss functions for a better ESG model. What's more, we can change the hidden layer size and the optimizer for MLP. As for ESG BERT model, we can see that Chinese BERT performs significantly better than FinBERT. What's more, with adaptation, the total loss of Chinese BERT has a 4.01 decline, and compared with the best performing traditional model EST, Chinese BERT with adaptation reduces the total loss by 30.64%. To sum up, the performance of Chinese BERT with adaptation is the best. Well, that's about it for now. Thanks for listening.